In this video, I will consider one example to find lattice coefficients. For the system's function h of z, obtain the lattice coefficients and sketch the lattice structure. Here system function h of z is given. We are supposed to calculate lattice coefficients. So let me write h of z, that is 1 plus 2.8 z inverse plus 3.4 z power minus 2 plus 1.7 z power minus 3 plus 0.4 z power minus 4. With the help of this h of z, first I will try to find the difference equation y of n. We know that h of z is nothing but y of z, that is output y of z divided by input x of z, that is 1 plus 2.8 z inverse plus 3.4 z power minus 2 plus 1.7 z power minus 3 plus 0.4 z power minus 4. I will rewrite this expression as y of z equal to x of z plus 2.8 z inverse x of z. I will multiply this x of z with all the terms on right hand side plus 3.4 z power minus 2 x of z plus 1.7 z power minus 3 x of z plus 0.4 z power minus 4 x of z. Now by taking inverse z transform, so inverse z transform of y of z is y of n is equal to, this is x of n plus 2.8 is constant. Inverse z transform of z inverse x of z is x of n minus 1 plus 3.4. This can be written as x of n minus 2 as power is minus 2 plus 1.7 x of n minus 3 plus 0.4 x of n minus 4. So this is the difference equation which is in direct form. We are supposed to convert this direct form coefficients into lattice coefficients. So I'll call this as equation number 1. Now we know that y of n can be written as x of n plus summation k is equal to 1 to m alpha m of k x of m minus k. Now let me expand this summation. I can write y of n is equal to x of n plus, I'll substitute different values of k. Alpha m is 4, alpha 4 of 1 x of n minus 1 plus, for k equal to 2, alpha 4 of 2 x of n minus 2 plus alpha 4 of 3 x of n minus 3 plus alpha 4 of 4 x of n minus 4. Call it as equation 2. So now comparing equation 1 and 2, I can write alpha 4 of 0 is equal to 1. So here the coefficient is 1. So alpha 4 of 0 is 1. So here we have alpha 4 of 1, that is alpha 4 of 1 is equal to coefficient of x of n minus 1 is, here it is 2.8. Similarly, coefficient of x of n minus 2 is 3.4. Coefficient of x of n minus 3 is 1.7. Coefficient of x of n minus 4 is 0.4. So now I can write alpha 4 of 1 is 2.8. Similarly, alpha 4 of 2 is 3.4. alpha 4 of 3 is 1.7 and alpha 4 of 4 is 0.4. So here these are the direct form coefficients. With the help of these coefficients, we are supposed to find lattice coefficients. That is, we need to convert direct form coefficients into lattice coefficients. So these three formulae we are supposed to use to convert direct form coefficients into lattice coefficients. Here we can see that Km is equal to alpha m of m. So here m is equal to 4. Therefore, alpha m of m means alpha 4 of 4. So alpha 4 of 4 is 0.4, which is nothing but K4. So we found one lattice coefficient, that is K4. The remaining coefficients are K1, K2 and K3. Now we'll find K1, K2 and K3 with the help of equation C. So in equation C, we are supposed to substitute different values of m and k, as I will explain now. So now substitute. Now put m is equal to 4 and k is equal to 1, 2 and 3. So in first round, I will take m equal to 4 and k equal to 1 in equation C. So in first case, I will take m equal to 4 and k equal to 1 in equation C, so that I can write. So here m is 4, 4 minus 1 is 3, k is equal to 1. So alpha 3 of 1 is equal to, here we have alpha m of k, that is alpha 4 of 1 minus we have alpha m of m, that is alpha 4 of 4 into we have alpha m of m minus k, that is 4 minus 1 is 3, alpha 4 of 3 divided by we have 1 minus alpha m of m whole square. Alpha m is nothing but alpha 4 of 4 square. So it can be represented as square or whole square. That doesn't make any difference. So alpha 4 of 1 value is, here we can see that alpha 4 of 1 is 2.8. That is 2.8 minus alpha 4 of 4 is 0.4. This is how we are supposed to substitute the values. Alpha 4 of 3 is 1.7 divided by 1 minus alpha 4 of 4 is 0.4 whole square. So simplifying this, we'll get 2.523. So alpha 3 of 1 is 2.523. Similarly, now I will consider m equal to 4 and k equal to 2 in equation C, so that I can write, I'll write for m equal to 4 and k equal to 2 in equation C. So now m is 4 and k is 2, that is alpha 3 of 2, we'll get alpha 3 of 2 parameter. Therefore I can write alpha 3 of 2 is equal to alpha 4 of 2 minus alpha 4 of 4 into alpha 4 of 2 divided by we have 1 minus alpha 4 of 4 square. Now substituting values, alpha 4 of 2 is 3.4 minus alpha 4 of 4 is 0.4 into alpha 4 of 2 is 3.4 divided by we have 1 minus 0.4 square. Simplifying this, we'll get 2.428. Similarly, for m is equal to 4 and k is equal to 3, that is last parameter 3 in equation C. So we'll get alpha 3 of 3 is equal to alpha 4 of 3 minus alpha 4 of 4 into alpha 4 of 1 that is m is 4, m is 4 and k is 3. Alpha 4 of 1 divided by 1 minus alpha 4 of 4 square. Substituting the values, 1.7 minus 0.4 into 2.8 divided by 1 minus 0.4 square. So simplifying this, we'll get 0.690. So here, as we know, alpha km is equal to alpha m of m. So here we have alpha 3 of 3. It means that m is 3. So it is nothing but km, that is k3. So we found k3 value. So already here we have found k4 value. Now we are supposed to find k2 and k1. Now I'll take m equal to 3 and k equal to 1 and 2. Now for m is equal to 3 and k equal to 1, in equation C, alpha 2 of 1 is equal to alpha 3 of 1 minus alpha 3 of 3 into alpha 3 of 2 divided by 1 minus alpha 3 of 3 square. Substituting the values, I can get alpha 3 of 1 is 2.523 minus alpha 3 of 3 is 0.690 into alpha 3 of 2 is 2.428, which we have found here, and this is k3, that is alpha 3 of 3, that is 0.690 divided by 1 minus 0.690 whole square. So calculating this or simplifying this, will get 1.618. Now similarly, for m equal to 3 and k is equal to 2, in equation C, we can get alpha 2 of 2 is equal to alpha 3 of 2 minus alpha 3 of 3 into alpha 3 of 1 whole divided by 1 minus alpha 3 of 3 square. So simplifying this, 2.428 minus alpha 3 of 3 is 0.690 into alpha 3 of 1 is 2.523 whole divided by 1 minus 0.690 square. Solving this, will get 1.312. As we know, alpha m of m is km. So alpha 2 of 2 is k2, which is equal to k2. So we found all three parameters, that is k2, k3 and k4. Now we'll find k1. K1 means we're supposed to find alpha 1 of 1. To get alpha 1 of 1, now put m is equal to 2 and k is equal to 1 in equation C. So therefore I'll get alpha 1 of 1, which is nothing but k1, is equal to alpha 2 of 1 minus alpha 2 of 2 into alpha 2 of 1 divided by 1 minus alpha 2 of 2 square. So simplifying this, 1.618 minus alpha 2 of 2 is 1.312 into alpha 2 of 1 is 1.618 divided by 1 minus alpha 2 of 2 is 1.312 whole square. So simplifying this, will get 0.699. So which is nothing but k1. So therefore now write the lattice coefficients, that is k1 is equal to 0.699, k2 is 1.312, k3 is 0.690 and k4 is 0.8. 0.4. So now by using the lattice coefficients K1, K2, K3 and K4, we'll draw the lattice structure. Lattice structure is shown below. So this is the lattice structure. Here we have input x of n. This is output y of n. This is z inverse, z power minus 2, z power minus 3, and this is z power minus 4. These are coefficients K1, K1. The value of K1 is 0.699. That is 0.699. Here we have K2. This is also K2. The value of K2 is 1.314. These all are adders. And here this and this are K3. K3 value is 0.69. Similarly, these two are K4, which is 0.4. So this is the lattice structure which is obtained using direct form coefficients. Thank you for watching.